implicitly to find dy over dx, which means I'm going to put a dot because this is a function. So let's start. Anyone? Anyone would like to help the derivative on the left-hand side?
Is it x
Careful,
times
this,
dy?
yes, careful, this is a product. So please understand and remember, always identify the product and use the product rule. I'm ready.
Is it x dy over?
We differentiate the first function and we get 1 times the second function plus. We copy the first function and now we differentiate the second one.
Is dy over dx?
Perfect. Minus. There is no dot here. I differentiate this and I get
1.
good.
1.
Plus.
Two dy over dx.
Perfect. And I differentiate the right-hand side and I get
0.
perfect. Perfect. So I see that these two have the variable. These two have to go to the other side. Positive 1 minus y. And here I have to factor out. So it's x plus 2 dy over dx. I cannot combine them, so I have to factor out the derivative. Finally, can anyone give us dy over dx?
1 minus y
Yes.
and then
Awesome.
plus 2.
All I have to do is just plug in now x equals -5 and y equals 2/3. So 1 minus 2/3 over -5 plus 2, which is -3. And this will be at the top. 1 minus 2/3 is 1/3 divided by -3 over 1, and I flip 1 over 3 times -1 over 3, -1 over 9. This is the slope. I think we have a few more minutes. Maybe we can finish one more. So I didn't get to this one. I don't remember what it was. Anyway, so let's move on to 23 from 341. 341. I'm going back, I guess so. 341, 23. Yes. The linearization. Do you think that is okay, or we need to look at an example?
Can we do one?
Yes. So we have in 23 on 341, we have f of x equals e to the x. And they're saying find L of x when a equals 2. Okay. We have to remember what this is. It's the same formula, right? So it's f of a plus f prime of a, x minus a. So f of a would be e squared. F prime of a will also be e squared because it happens that this is the same with the derivative. And then x minus 2. And this is it. There is nothing else. This is the line that approximates this function near 2. Now let's see what else they want. Use the linearization to approximate e to 2.1. And then use a calculator to approximate e to 2.1. Fine. So in part B, so this was part A. So in part B, I have L f of e to 2.1. And in part C, they want f of e to 2.1. Fine. So I'm going to put both in the grafting calculator and just plug in. So in y equals, clear, clear. I'm going to put the linearization first. E squared plus e squared again. And in parentheses, x minus 2. Now I will put in the function, which is e to the x. And I go back, and in both of them, I plug in 2.1. They have to be very close to each other. So the linearization is, I don't know how many digits they want. I'm going to copy 4. 8.1280, and the other one, 8.1662. Okay, then what else? What is the difference between? Fine. Okay, so the difference will be, so 8.1662 minus 8.1280, and I'm sure you can subtract those. Okay, so I'm gonna stop here. I'm sorry, I really wanted